All right, so just to kind of explain what's going on. The reason they gave us these speeds and showed us and told us that this was constructive interference was so that we could figure out that the two original beams are out of phase. That's important. We have to know that. That way, when we put in the new things, we can see what happens. All right, so let's go ahead and do this. Okay, and the first, I'll do this part in yellow. The first part of the problem, A, says this is 0.9 C. It says this, yeah. Oh, that's right. Okay. Okay, hang on. And then this third one will be 0.7. Okay, so because of this reflection, so then we know that the path difference, well, actually, the path difference, well, we don't know how thick anything is, we don't know what the wavelengths are. So what are you saying, Alan? Okay, I see what you're saying. Okay, well, the thing he's bringing up is something like this. If we just did something simple like this, and this went from fast to slow, and then this light did this kind of thing. So here's our point P, right? When we do this, we say this 2D is the path difference. So then we can say that path difference is equal to, or I'm sorry, if we do this as slow to fast, yeah, that should be word. I'll look at the example we did for soap. Okay, when we talked about soap bubbles, this is like air, and this is soap. Slow. Remember when we talked about this? Okay. And then this bounces off. So this is going from fast to slow. So the one that's bouncing off the surface here, and then this is air again, so that's fast. When the one that bounces off the surface, this is going to have a 180-degree shift. And then the one that bounces off the bottom and comes up, that's not. So then if you look at the areas on the bubble that are bright, right, then we know that this path difference, that we know that's 2D, and then we can say that that path difference, which is equal to 2D, has got to be equal to lambda over 2. Because normally, path differences, like if it's bright, you would expect it to be what? You would expect delta to equal what? Okay, fine, that's great to do that. Right? If we know it's bright, and you expect it, if it's bright, you would expect delta to be lambda. But if it's bright, and you know that one of these had a shift, then you know that the path difference is lambda over 2. Right. So here, they tell us that this is that's a constructive interference. Yeah, it's constructive. So this is a bright line. So then we know that the path difference is going to be 2D on this side. But if this is bright, then we have to make sure we account for the shift. Right? So so then you're saying this should be lambda? Because I'm seeing if this is going from, oh crap, I forgot the other one. The other one was slow to fast on the top, and fast to slow on the bottom. So then, yeah, I think it should come out to something like this. Is this what you're saying? Yeah. Okay, I agree with you. Did I do something different before? Oh, okay. So I guess what I'm saying is the path difference part of it will be what we use, like if we're trying to determine how thick this is, like if you want to know D. But if we're just saying this is bright, then me and my single piston mind does one thing at a time, says, oh, bright, that means lambda. Okay. And then the trick of this problem is they're trying to trip you up by putting the original speeds. Because the original speeds were slow, fast, and slow. Because then when they do this, that shifts one of them by half lambda. Which means the brightness has to account for that. So because one of the beams is shifted, this is what we do.
Both beams are shifted the same.
Exactly. If both beams are shifted the same, if both beams shift 180, then it's the same. So, I don't know, maybe it's kind of like if Alvin and I are walking down the hall, and for some reason, it has nothing to do with Nazi Germany, we're goose-stepping. So we're walking like this, right? And let's say that our legs are the same length, so we're in phase. Does that make sense? So when we're in phase, boom, 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 it's going to get louder. So we get this sort of bright thing. Well, if, I don't know, Van doesn't like that, so she comes up and then like kicks one of our feet, so that we now go out of phase. So when I come down, he goes up, and that way it kills half the sound, so it's less loud, right? So when we're stepping together, it's in phase and it's bright. When we step opposite, it's less loud because we're out of phase. Does this make sense? Yeah. Yeah. Okay. So then here's the part of the analogy. So but let's just say when we walk into a wall or something, we just turn around, okay? And when we turn around, like that can shift us. So if one of us bumps into a wall and the other one doesn't, and we get shifted, then that guy walks differently. No, that's not working. That was going so well until it fell apart. Oh, yeah, okay. No, I'll just use it. Okay. What got us out of phase in the first place? Yeah, Van kicking our feet, right? So her interaction is what changed us. So we were normally in phase, marching down the hall. And then she didn't like it, so she kicked one of us, and that took us out of phase, right? So in order for us to get back in phase, what would you have to do? Yeah, kick us again. You kick one or the other. It doesn't matter which one, right? But if you kick us again, then boom, we'll get back in phase. So what happened here is we were both marching out of phase when we started. And then when we came down, right, this did not result in a kick, but this reflection resulted in a kick. So we were out of phase, and then you kicked us here and got us back in phase, and that's why that was constructed. So we were shifted by pi over 2 originally. And then, because you wanted to hear, I don't know, the loud marching noises, you kicked one of us. That collision is what did it. And then that made us go in phase, so now it was louder. You kind of see what I'm saying there? So the thing that makes a shift is that kick. Okay, and if you can accept that that kick is like a reflection. The kick is this reflection right there. Because when you reflect, and again, that's the wrong numbers, but if I quickly redraw this, oh wait, it's 3, right? And this was slow, this was fast, and this was slow. I think this was 0.7, this was 0.9, and this was 0.8. Okay, when you go from fast to slow, that's the kick. So this beam that went like this, no kick, because it's slow to fast. But this beam, boom, right there, it got kicked. That was the kick right there. And that shifted it. So this beam was, I don't know, let's call it 0 to pi, right? But this beam coming in was pi to 2 pi. When it got kicked, it became 2 pi to 3 pi, which is the same as that. And in phase. Right? So actually the analogy works out, right? The kick is when you go from fast to slow. I mean, that kind of, hopefully that makes sense to you, right? Like if you're just walking along, and you're walking along through air, and all of a sudden you step into water, wouldn't that mess up your walk? Right? It's the same kind of thing, right? Or if you bounced off something, whatever. I'm not going to kill it with the analogy, but you get the idea. So this is actually working out. Fast to slow is a kick, and it changes, it shifts the phase. So when we go back to here, and like I said, remember, the first part of the problem, where we were given, remember the first part, this was 0.7, this was 0.9, this was 0.8. The first part told you that this was constructed, because they're trying to see if you can pick up that they're shifted by power 2. So then now, they're asking for the rest of them. Is it in phase, is it out of phase, or is it something in between? Okay, all right. So then for part A, they give us this. So they give us the yellow. So I'm going to get rid of this because I don't know if this is bright anymore. We're going to try to figure that out. So in the yellow, 0.9 to 0.8, is there a shift? Is there a shift here? Is there a kick? Fast to slow. There is a kick. Do we see that? Okay. And then what about 0.8 to 0.7? Yes, there is also a kick. A double kick means we're going to both be exactly the way we were when we started. And how did we start? Out of phase, you see? So this problem is like this. Alvin and I are walking down the hall, but we don't want to make noise. So we're out of phase. He steps down, I lift up. I step down, he lifts up, right? That way we're totally out of phase. And as we walk down the hall, then somebody came up and kicked me because they wanted to hear the noise. And then someone else didn't want to hear the noise, so they came up and kicked Alvin. So those two kicks made us go back to the way we were. Does this make sense? Hmm? Yes. Okay. Okay, so what are we going to get here? Destructive or darkness?
We should have darkness.
Okay, this is, to say the least, this is difficult to understand. Okay, and I don't know, actually, someone said earlier that the analogies make it worse. Well, I don't know. Right? Well, I figure there's a little bit of, everybody can kind of go, oh, yeah, I like it. So that's fine. Maybe it'll help you remember. All right, questions on this part, on part A? All right, so then we go to part B. And part B says, I'll go with green here. Part B says this is 0.8, this is 0.6, and this is 0.7. 8, 6, and 7, yes? Okay, so remember, we started out of phase, right? We started out of phase. So we come in. What happens at 1 to 2 boundary? Yes, there is a kick, right? And remember that kick is lambda over 2, right? It shifts you by lambda over 2. What about 2 to 3? No kick, right? There is no kick. So this is still normal. So what is now going to happen at point P? Yeah, you're going to get a bright spot again. Right? Because we were out of phase, one of them got kicked, and because one of them got kicked, now we're in phase and we're bright again. So this one works out just like the first one. Just what they did was, in the original problem, they shifted the kick came at 2 to 3, right? Okay? Yeah, because it's 0.8 to 0.9. The kick came at 2 to 3. The non-kick was at 1 to 2. Then here, they just flipped it, and they put the kick at 1 to 2 with no kick at 2 to 3. Questions on that part? Okay, this is going to be an extremely long video. But whatever works. Okay. And this is going to go with pale blue. And we'll say, oh look, it matches the color. This is 0.6C. This is 0.7C. And this is 0.8C. 6C, 8C. Okay. So again, I ask you, where's the kick? Oh. Kicks only occur when? Fast to slow. Is there any fast to slow here? No. Therefore, what are you going to get at point P? Yeah, destructive or darkness. Excellent. Good job. Does that make sense? And so, Alvin, the 2D absolutely is important. That's going to come into play where you're going to be asked to calculate like a frequency, or you're going to have to be asked to calculate the thickness of something. Okay, question?